We shall now consider another system of interconnected bodies known as the Atwood machine. This consists of two masses connected together by means of a string that runs through a freely rotating pulley. When the masses are released in this position, we would obviously expect a 6 kilogram mass to lower and the 4 kilogram mass to rise as the pulley rotates. This is because there is a net force, and therefore the bodies will accelerate in the direction of the net force. The external forces acting on the system of interconnected bodies are, for the 4 kilogram mass, of course, its weight downwards at 40 newtons, and for the 6 kilogram mass, its weight downwards at 60 newtons. The string that is used to interconnect the bodies is obviously under tension, pulling the 4 kilogram mass upwards and slowing down the 6 kilogram mass with also an upward force. So as this is one rope, the tension is exactly the same everywhere. But the tension is an internal force, and therefore we cannot consider it as an external force. Applying Newton's second law to the system, Newton's second law states that the net force will cause the mass to accelerate. The net force in this case, the net external force that is, it's 60 newtons minus 40 newtons. And the masses that are moving, or the masses that the net force is accelerating, are 10 kilograms, because both masses are accelerating under the action of the net force. Therefore, that leads to an acceleration of 2 meters per second squared. The next question is, what is the tension force? We can easily find this by looking at a free body force diagram for each of the masses. Let us look at a free body force diagram for the 4 kilogram mass. The two forces that are acting on the 4 kilogram mass is 40 newtons downwards and T upwards. T must be greater than 40 newtons because 4 kilogram mass has an upward acceleration. Applying Newton's second law equation in this case, we have the net force, wrong one, the net force to be T minus 40 newtons, and that causes the mass of 4 kilograms to accelerate at the previously found value of 2 meters per second squared. Mathematically, it gives us a tension of 48 newtons. Similarly, we can repeat our analysis by looking at a free body force diagram for the 6 kilogram mass. Now, if we look at applying the Newton's second law equation for that, again, F net equals mass times acceleration, the net force in this case is 60 newtons minus T. As the 6 kilogram mass has a downward acceleration, obviously 60 newton force is greater than T to have a downward resultant. So the net force, which is 60 minus T, causes the mass of 6 kilograms to have an acceleration of 2 meters per second squared, and thereby giving us a tension force of 48 newtons. Again, this is no surprise because we are talking about the same string that is interconnecting the two bodies.